So let us copy this column 1 and column 2. So copy this column fast. So you have 4 entries in column 1 and 4 entries in column 2. So let us copy the column 2. So we have 4 entries in column 2. P, Q, R, S are the entries. So you have to match the entry of column 1 to entry of column 2. Not necessarily each element has to be matched. You can have more than one entries for one column. So like for A, you can have possibility either P, Q, you can have possibility Q, R, even you can have a P, Q, R, S, all 4 possibility. So you have to decide yourself. So let us try, take 1 minute time. This is one of the good problem. So this covers the concept of mechanism. This kind of question is these days are very often asked in JEE. So this is a very good question and it covers the concept of mechanism. So let us take some time. Okay, let us discuss. So let us discuss easy one the first. So let us discuss first D part. So this is the easiest one. So this says PHCH2CH2Br and CD2CH2Br reacts with same rate. This gives me a hint that is CH bond or CD bond is not involved in the rate determining step. If it is involved, then the rate will not be same. So this means CH bond or CD bond is not involved in the rate determining step. So now I can say CD, so breaking of CD, so CD CH bond breaking is not in the RDS step. That is rate determining a step. Are you getting? So this means now we have only one option. So this reaction can be either E2 or it can be either E1. So if this is E2, what you will have in case of E2, you have PHCH and here H, and then you have CH2Br. So if this is E2, in that case base will take this H plus, this goes here and this departs if this is E2. But in this case hydrogen is in the RDS step, so this is not a possible option. So now I have only one option. In the rate determining step I have to make a carbocation, and that carbocation basically loses H plus in the next step. Are you getting? So in the first step you have to generate a carbocation and then you have to lose one H plus. So this means the reaction is E1. Are you getting or not? Because this has to be only possible. So what is the possible solution you will have? So you will have something like this: PH CH2 CH2Br. The first step will be loss of Br minus. So you will get a carbocation. Of course that carbocation is a primary carbocation, so it will rearrange soon. So you will get this primary carbocation plus Br minus, and this will be RDS. This will be slower step and this will be RDS. Now the next step you will have, that is a carbocation rearrangement. So you will have PHCH2 CH2 plus. So if I rearrange the hydrogen from here to here, so you will have PHCH plus CH2, and the next step I can lose H plus. Are you getting it? So third step will be simply loss of H plus, PHCH plus CH2. Here you have CH3. So let us make one hydrogen. Now in the next step, if you lose one H plus, you will get PHCH double bond CH2, and the same thing will happen with CD2 bond also. In this case only you have to lose H and D. Are you getting? So in this case you have to lose make carbocation, and then you have to shift deuterium, and then you have to lose hydrogen or deuterium, anything you can lose. So mechanism will be E1 in this case. Are you getting? And this will first order reaction, because this is a E1 is first order. So this will be what? So option A, P as well as S both are true in this case. So P and S are true. Are you getting or not? Let us discuss next one. So now let us discuss part A. I think all of you have copied this one. If you have not copied, please copy fast. Now let us discuss part A. So if you see part A, this is also easy, and question says on treatment with alcoholic OH this gives dips as a major product. This means hydrogen, breaking of hydrogen bond is in RDS. If this deuterium breaks, then you will have a double bond here. If hydrogen breaks, then you have a double bond here. This suggests me, and hydrogen bond is a weak bond. So breaking of hydrogen bond is in RDS. Breaking of CH bond is in RDS. Are you getting? Now you know. Breaking of CH bond is in RDS. So if this is in RDS, I have only one possibility. Reaction will be something like this: CH3 CH Br, and then you have, if you have hydrogen, then CH3. If you have deuterium, then you have CD3. Now the next mechanism will be something like this. So this X plus, this goes here and this goes here. So this will be E2 mechanism. So in this case, mechanism is E2, and E2 is what? So option Q. So this is, so in this case, Q option is correct option. Now let us discuss part B. And what the part B says, and B says this reacts faster than this. Oh, this is the B. So we have discussed B. We have not discussed this one. So on treatment with this gives this major product. This we have discussed. Now this one, B part. PHCHBrCH3 reacts faster than this CD3. Once again, this has to have something to do with carbon hydrogen bond, because this reacts faster. So once again, this is a E2 mechanism. Are you getting? Because CD bond does not break in the redetermining step. In this case, CH bond breaks. So in this case again, for B also you will have option Q, that is E2 case. In this case you also have E2. CH bond breaking is in RDS. CH bond breaking is in RDS. Are you getting or not? So this is again E2 mechanism. Now the part C. C is quite interesting. So you see, now if you see C1, so you have this on treatment with this and this. So this is your base, and this gives this one. Now you see one hydrogen has been replaced from this carbon. Now I am getting deuterium. How this is possible? So you see, you have initially PHCH2 CH2Br. Now if this is treated with C2H5OD, C2H5OD and C2H5O minus, so this is basically acting as a base, and the final product you see, this is something like PHCD double bond CH2, and this gives me a hint. Since there is a deuterium, so this means there must be a minus here that has taken D from the solution solvent, and then only I have deuterium here. So this gives me a hint there should be something minus. Are you getting or not? And that is possible only if this base CH CH2Br, if this base OET minus take H plus from here, and in that case you will have PHCH CH2Br. Are you getting? So you will have a minus here. Are you getting? And now this minus can attack here and this Br goes, so you will get the product. Basically this step will be a faster step because this is acid base reaction. Now next step, you see what will happen in the next step. You have here PH CH minus and then CH2Br. So in the next step, this carbon ion will push off this bromine. So you will have PH CH double bond CH2. Now this will be a slower step. Are you getting or not? So this step is a slower step. But still I have not got here CD. I have got CH. So I have to do some more modification. That is possible. You see, this step is a faster step. Generally faster steps are reversible step. So if this step is fast and reversible, what will happen? This minus can take D. So OETOD. So you have ETOD. So this minus basically can take deuterium from here and then it can go here. In that case you will have CD bond and H bond. In the next step, if this H goes, then you will have here CD bond. Are you getting what I am saying? You have this step. So let us say this step is reversible step. So what can happen? You have PHCH minus CH2Br, and basically this minus can take HD plus from solution. So if this takes D plus, what you will have? You will have PHCD H CH2Br. Are you getting? And now in the next step, if you take H plus, so if you take H plus, you will have PHCD CH2Br. Are you getting? And now if this carbon and pushes off this bromine, expels this bromine out, this step is a slower step. So you will have PHCD double bond CH2. Are you getting or not? And now this step is a slower step. This is also RDS. Now you see the mechanism in this slower step. We have a carbon ion that is pushing off this bromine. So this mechanism will depend upon the concentration of this carbon ion. This is basically conjugate base, and this depends only on this carbon ion. So this is a E1CB mechanism. Are you getting? So this mechanism is E1CB, and E1CB is again first order reaction you have. So E1CB is R, and this is the first order. So this S also I have to. So you see your option. So R is E1CB and S is first order. So this is R as well as S, both R and S. So this is a quite interesting problem. So you see, by changing hydrogen to deuterium, I can always form what will be the reaction mechanism. We'll discuss the next problem. You have to have revised this problem one time more, and this is a quite good problem. Anytime they can ask in the exam.